Take a look at here at answering these questions, 1997 AP Calculus BC multiple choice questions. The first one says part 7 is based on this graph that says function f is defined on a closed interval 0 to 8. The graph of its derivative prime is shown above. Question 7 says the point 3,5 is on the graph of this function. An equation of the tangent line to the graph of f at 3,5 is as given. First is identify an important piece of information. Remember that the y coordinates that you see on f prime represent the slope on the original function. Specifically, when x has the value 3, look carefully here, it's going to be from 3 up to 2, value of the slope on the original graph. So that means that the equation of the tangent line would be this. You would take y minus the given value of 5, and then here you would set this equal to y prime at 3, which from the graph is 2, and then you do x minus the given value of x, which is 3. In other words, what it's telling you is that the equation is right here. C, y minus 5 equals 2 times x minus 3. For the next part, it says, how many points of inflection does the graph of f have? What happens at points of inflection? The second derivative switches from positive to negative or negative to positive. How does that relate to the first derivative? Think about it. Look at this peak point on the first derivative. What I'm marking basically is an indication of the second derivative. Because you see here the second derivative is positive, it would look like this. And then here the second derivative is negative, so it would look like this. In other words, because the second derivative switches signs from positive to negative, on the original function you have an inflection point. Same thing over here. Second derivative is negative, then it's positive, which means it would look like this. It would switch from negative to positive. That means on the original function, inflection point. Next one, at 3 itself. So let me just move the segment out of the way here. That means the following then. Here is going up, and then here is going down, which means that the second derivative would look like this. It would be positive and then negative, which means on the original there's an inflection point. Same thing at the 4 is going down, then is going up. Let me make that in red, which means that the second derivative, again, not shown here, just like f is not shown here. The second derivative at that point would switch, because you see the segment has a negative slope, that means the second derivative is negative. This little segment has a positive slope, so the second derivative is positive, which means on the original function, you have an inflection point. At 5, on the graph of f prime, going up and then going down, which means that the second derivative here is positive, and then it's negative on the other side of the 5, which means on the original function f, not shown here, is an inflection point. Lastly, same thing at 7. You see here the first derivative is going down and it's going up, which means that the second derivative here would be, well, it's going down, so it would be negative. On the other side, it would be positive, which means that the original function has an inflection point. If you count them, it's 1, 2, 3, 4, 5, 6. In other words, the correct answer here is 6, E. There's 6 inflection points on f. For the last part, at what value of x does the absolute minimum of f occur? So take a look here. You can tell by looking at the graph that the following is true. So f increases from 0 to 6. How do we know that? You see, f prime is positive when x begins at 0 and ends at 6. All of these values except 4, all of those values are positive, which means that the original function that's shown here is increasing essentially from 0 to 6. Now, again, going by the graph, you can also tell that f decreases, okay, from, let's see, 6 to 8, because f prime is negative there. However, clearly the decrease from 6 to 8 is way smaller than the decrease from 0 to 6, right? Because from 0 to 6, as you can see, there's a lot more area there than there is in terms of area that's negative from 6 to 8. So in other words, what it's telling you is this. If you begin at a point somewhere on f, you're going to increase a lot, and then you're going to decrease from 6 to 8, but less, which means that the absolute minimum would have to be all the way on the left side, somewhere over here. In other words, remember the following important point, guys. You see, what does this do right here? Think about this. You have here the following. You're going to do a definite integral, and it's going to go from 0 to 6. This will just represent essentially the net change. How do you find it? Well, remember, you're integrating f prime of x this way. In other words, this represents the change from as low as, say, point up to basically a highest point. So in that case, that might be represented in the picture here as follows. Let me move this graph around. You really have to understand this part. So I could represent this by this brace right here. See, so this brace represents the change that we accumulate using our integral here. When the integral gets a negative integrand into it. So in other words, you see here f prime is always negative from 6 to 8. That would be represented by this quantity right here. So in other words, that would be represented by the definite integral essentially from 6 up to positive 8 of f prime of x dx this way. In other words, whatever you accumulate from 0 to 6 is clearly bigger than whatever, for example, you lose from 6 to 8. Okay, friends, well, that is it then for me. Thank you all so much for watching. Please leave a like, please subscribe. I will see you in another video.